All right, in this video, let's talk about what a set is. Now, a set, the best way to look at it is it will show you what is unique in, say, a list. Or if you create a dedicated set, you can make a comparison and see exactly what's unique. And there's a couple of different ways that you can create a set. The first one is you can call the function of set like that. You can also, though, use the squiggly brackets just like we did with the dictionary, and you can throw in different objects in there. The difference between this and a dictionary, though, you don't have to do a key and value pair. All right. So if we do a type on A now, you can see it's a set. To give an example of another way, let's say we have B, which is going to be a list of 1, 2, 3, 4, 5, 6, 7, 8. So you could also create that as C is now equal to a set of B, right? Type C is a set. If we just look at C and if we look at A, they're pretty similar, other than there is just a 9 that happens to be living in set A. Now, just like with all of the other ones we've looked at, you can run dir and dig into a set a little bit deeper. So let's start digging into some of these. Clear and copy, by now you should know what those already do. But difference is, that one's a little bit new. So let's make a new one. 1, 2, and 3. And B is going to be, let's just say 1, 2, and 4, and 5. So if we want to do a difference on A, we would do it like this. A.difference, if I can type, difference of B. So what is that going to return? The best way that I can think of to put that is it says if in A and not in B. If in A and not in B. It's the best way I can think of to list that out, and that's what that difference is going to be. Now, if you want to do it as a difference update, which is the next one there, what do we have now? That trimmed us all the way down to just a 3. All right, so that's all that we are going to see in that one. Let's reset A back to what it was. And to run that again just one last time. Difference B. Again, it's just going to show you what you have in A, not in B. Discard. This is kind of an interesting one. So let's redo that. And let's do A.discard. And let's do 1. Okay? Now we look at A. 1 is gone. So discard is very similar to remove. We'll just kind of skip over to that one really quick. But let's say if we do a.remove 1, we're going to get a keyword error because now 1 is gone. But if we do a.discard 1, it's just going to run the command. It's not going to error out on us. So both of those will remove. Discard will remove and it'll let you run the command whether or not that object actually exists. Remove will give you a keyword error. Intersection. Let's make sure we've got these 1, 2, 3, 4, 5. Okay, let's set B again, and then we'll do an intersection. So 3, 4, 5, 9. Let's just do it like that. So A dot intersection of B, that is going to show us what is shared between those two different sets. So if A and in B, those are our intersection points. So those are the ones that we have between the two. Okay, A, make sure that's still the same. And then if we do an intersection update, what's that going to give us now? Just 3, 4, 5. So by doing that, we are updating A to only show those that are in A and B, and now A is simply just that intersection point. So set that back. Is disjoint and is subset and is superset. I almost never really use those ones. Pop is going to be just like some of the other ones that you've looked at, with the difference that it is going to start taking it off of the front rather than the back, like it will if you're doing a pop on a list, right? So we just popped off 1, popped off 2. The next one will pop off, 3. We already did remove. We already know what that is. All right, let's look at some of the other ones that are still remaining. Let's look at a symmetric difference. So this one is going to be kind of interesting. It is going to create a new set with elements that are either in A or B, but not both. So let's, as you can see here, I already predefined these. I had to step away and grab a drink of water there between that last video. So you can see we have A and B. Go ahead and create those on your own terminal. Give you a second to do that. And then let's do a symmetric difference. Let's actually just create a new one. Let's name it S. And so S is going to be A dot symmetric difference of B. So what that did is that is creating elements that are either in A or B, but not both. So if you look through there, we have 1 up here, but we don't have a 1 down there. We have a 3 and we have a 3, and that's why we didn't get a 3 here. 5, no 5, so 5 ended up in there. We have a 6, but not a 6 up here, so 6 ended up in there. Here we have an 8, but we don't have an 8 up in A, so that's why it ended up in there. So that's what a symmetric difference is going to be. It is going to say elements that are in A or B, but not each other. So the last one we're going to look at when it comes to a set is we are going to look at a union. Actually, let me make sure I've got this as that. A equals set. A. All right. dir of A. We're going to look at a union. So let's create a new one. A equals 1, 2, 3. B is equal to 4, 5, and 6. So what a union is going to do is it is going to really combine these two with unique values. So actually, let's update B one more time. Let's throw another 3 in there. All right, let's do that. So now we have A and we have B, and they do overlap on 3. So if we do an A dot union of B, we are now going to create something new. Actually, let's just create a new variable so it's easier to see. Before you hit enter, do V equals A dot union B. Okay? So now you can see we have done a union. We have married those two together, and we have removed any of the duplicates, which the only one there was 3. And so we now have that as a union. And that's about all we've got for these data set videos. So we'll move on to the next section after you do a brief quiz.